Okay, here is a numerical problem which is given, but to solve this you need to understand a very important concept under electrochemistry, that is the relationship between electrochemical cell and Gibbs energy. Electrochemical cell and Gibbs energy of the reaction. So we need to understand about this if we have to solve this numerical problem. So you know what is electrochemical cell. So example is voltaic cell or galvanic cell we have. So in galvanic cell, if we have to get maximum work, to be done, then the charge has to be passed reversibly. Okay, so in general it is that electrical work done, generally I am writing this, electrical work done is the product of charge passed and electrode potential. Okay, so electrical work done will be maximum, or it is the product of charge passed into electrode potential. Now electrode potential we know here, if we have to get maximum work from a galvanic cell or a voltaic cell, then charge must be passed reversibly in case of galvanic cells or voltaic cells, I mean to say. So what has to be done? Charge has to be passed reversibly so that we get maximum work done there. Now here when we speak about electrochemical cell, Gibbs energy, what happens if charge is passed reversibly? Then Gibbs energy also becomes negative. Gibbs energy becomes negative. How do you give? If delta Rg is, just make a note, if delta Rg is Gibbs energy of the reaction, Gibbs energy of the given reaction, and Nf, N means number of electrons, F is Faraday's constant. If Nf is amount of charge passed, and E is the electrode potential, then we can give the expression, or then we get the expression as, so you will write, if delta G is equal to Gibbs energy, Nf is this, E is this, then therefore delta G is equal to minus Nf E. E means cell potential, E cell we write, or Nf E we write. Very important expression, because the numerical problems will be solved based on this. In standard condition, say when the temperature is 298 Kelvin, then we write E cell as E naught of cell. We get it as E naught of cell. Therefore, you get the expression at standard conditions, delta G naught is equal to, that is when the concentrations of the species are unity, then delta G naught is equal to minus Nf E naught. So hope you know what is E naught. E naught is standard electrode potential, delta G naught is standard Gibbs free energy change, Nf is product of N into F is amount of charge passed here. So this is the expression. So based on equilibrium constant, there is one more expression for this, where we can write delta G naught is equal to minus RT ln K, where K is the equilibrium constant. So this you have however studied in thermodynamics chapter when we study the relationship between Gibbs free energy change and equilibrium constant. We got this expression. So in this unit, the most important one is how you can relate Gibbs energy and electrode potential, because the numerical problems, most of the numerical problems can be based on this formula also. So let us just note this, note down what are the things here. And for example, if suppose we are considering Daniell cell. In Daniell cell, how can you calculate Gibbs free energy change? That is, how can you calculate delta G value there? If you have to calculate delta G value, then see, this is the expression, isn't it, for Daniell cell? Zn plus Cu2 plus, I'm just generally writing, gets converted into Zn2 plus Cu. So how many electrons are involved? 2 electrons are involved. That is what we want to know. So E naught of cell, if it is given, you can directly substitute it here. If delta G is given, you can directly substitute, and you know it is energy, Gibbs free energy. So in joules you will have to write. You just need to calculate N from these reactions if such reactions are given. So here you know 2 electrons are involved. So we will write it as delta G naught is equal to minus 2 F E naught, and then you will calculate. Clear? Now we will solve the numerical problem which is given here. So the question says calculate the standard energy, that is standard change in free energy for the cell prepared by combining Zn, Zn2 plus and Mg2 plus electrodes at 298 Kelvin, and here it is given the standard electrode potential for zinc and standard electrode potential for magnesium as minus 0.76 and minus 2.37 respectively. So what you have to see here, you can see that this is oxidation half cell, this is reduction half cell. Therefore, first you will have to see here when Zn and Mg is given. So if you check out the electrochemical series, here magnesium will be undergoing oxidation and zinc will be undergoing reduction. So this will be the reduction half cell. Therefore, first what we have to do, we know that standard Gibbs free energy change means we know that delta G naught is equal to standard, they have asked. So delta G naught is equal to minus NF E naught, isn't it? But they have not given you E naught value directly. Instead, they have given you E naught of zinc and E naught of magnesium. So what you have to do, you have to calculate E naught value and then substitute it here. Okay. Now, here, what is the formula to calculate E naught of cell? E naught of cell is equal to E naught of right hand electrode minus E naught of left hand electrode. So right hand electrode means, what is the value here? Minus 0.76 minus here minus of minus 2.37. So just calculate and check out what value you will be getting there. You will be getting probably around 1.61 volt. This is the electrode potential, but we have to substitute it in the given formulae. So delta G naught is equal to minus NF E naught, right? We will write the equation here. So Zn 2 plus Mg 2 plus Zn. So Zn undergoes reduction. Why? You will have to see the negative value here. You know about electrochemical series. If it is highly negative, then whether it is more reducing or less reducing. Based on that, we have got this particular idea, that which is oxidation and which is reduction half cell. Now delta G naught is equal to, in this how many electrons are involved? Zn2 plus getting converted into Zn, so 2 electrons. Mg into Mg2 plus, again 2 electrons. Therefore 2 electrons. So in the place of N, NF E naught, so in the place of N I have to write minus 2. F value is 96,487 coulomb. Yes, per mole. E naught value is what you have got now. E naught value is 1.61 volt. Now substitute it and calculate what is delta G naught value. You will get the value around minus 310.730. Now you have got this. What is the value you have to write? Into 10 to the power 3 you will get, otherwise kilojoule you can write, or you can also write it in terms of that is 10 to the power 3 also. So this is the numerical problem related to calculation of Gibbs free energy, which you can see that most of the questions will be related to this. Now let us see next numerical problem, where it is asked to calculate the change in free energy at 25 degrees Celsius for the cell reaction Cu bar Cu2 plus, which is mentioned as 1 molar, double bar, that means a salt bridge, Ag plus, again it's mentioned to be 1 molar, bar Ag, if E naught of Ag is equal to 0.8 volt and E naught of Cu is equal to 0.34 volt. So what is asked? You are asked to calculate the change in free energy. Change in free energy means delta G. Here cell reaction is given where copper electrode and its solution constitutes 1/2 cell, and silver electrode metal and its solution constitutes 1 more half cell, and the electrode potentials of copper and silver is also given. So first, what are we supposed to do? We know that delta G naught is equal to minus NF E naught. But what do we want? We want E naught value here. We want what is N. So how can we calculate E naught of cell? E naught of cell is equal to electrode potential of right hand electrode minus electrode potential of left hand electrode. So for silver and for copper, the electrode potentials are given. So the one which undergoes reduction will be the one which has more positive, that is more positive value here of silver. Therefore this will be electrode potential of silver minus electrode potential of copper. Therefore you get it as 0.8 minus 0.34. Calculate what is the electrode potential expected. You will get the answer as 0.46 volt. So we have got what is E naught of cell, and we need to calculate what is delta G now. So to calculate delta G, first let us see about the reaction. When you write the reaction, you know that here copper will form Cu2 plus, whereas Ag plus forms Ag. And you know here 2Ag and 2Ag. That means 2 electrons of Ag and 2 electrons of copper. Therefore, number of electrons involved is 2. N is 2 here. So we have to substitute for this formula. It becomes delta G naught is equal to, in the place of N it becomes 2 into Faraday's constant value is 96,487 coulomb per mole. So into 96,487 into electrode potential value, that is 0.46. Calculate and write the value for delta G naught. The expected value for delta G naught is minus 88,780 joules. This is the expected answer for the change in free energy value for the cell reaction of copper and silver that has been given. Let's solve one more problem. Calculate the change in free energy for the cell Mg bar Mg2 plus, where it's mentioned as 1 molar, double bar Ag plus bar Ag if E naught of Ag is equal to 0.8 volt and E naught of Mg is equal to minus 2.37 volt. Again, change in free energy for the cell. I need not mention you the formula. So how do we write the reaction as? Reaction is Mg plus 2Ag plus gives Mg2 plus Ag. This is the reaction. So how many electrons are involved? Again 2 electrons. Here Mg2 plus 2 electrons, 2Ag plus 2Ag. Again 2 electrons will be involved. First we have to calculate E naught of cell. Electrode potential of right hand electrode minus E naught of left hand electrode, which is equal to, first comes the positive value here, highest positive value 0.8 minus of minus 2.37, where you get the value of E naught of cell as 3.17 volt. Now you have got E naught of cell. You have to directly substitute to that E naught value in the formula. Formula is delta G naught is equal to minus NF E naught. Therefore minus N value, you know, it is 2. Number of electrons involved here is 2. So 2 into 96,487. Very easy problem. Into 3.17. Here you need not take logarithm of any, you need not bother about anti-logarithm also. It's just calculating E naught of cell and substituting it in the formula. So you know energy means it in terms of joule you will have to calculate. Sometimes they would have given you the value of Gibbs free energy and they'll ask you to calculate the electrode potential. That also you should be knowing. Here delta G naught value, it comes out to be around minus 61,000 or 6 lakh 11,810 joule, or in other ways you can write this as, or that's equal to minus 611.81 kilojoule. You can convert it into kilojoule and write the value also. So this is also a possible thing which you can do for the conversion here. So that's how Gibbs free energy is calculated. Now we will check out one more problem. That is, calculate the EMF of the cell prepared by combining zinc bar ZnSO4 and Cu bar CuSO4 at 298 Kelvin. Given E naught of zinc is equal to minus 0.76 volt and E naught of copper is equal to plus 0.34 volt. So what is asked? You are just asked to calculate the EMF of the cell which is prepared by using zinc electrode and copper electrode with zinc sulfate and copper sulfate as the electrolytic solutions at 298 Kelvin. Here the electrode potential of zinc is also given and as well as copper is also given. So you know that it's nothing but of Daniell cell the question has been asked. So how are you supposed to calculate? You know which has highest standard reduction potential will be the right hand electrode. Okay, just make a note of this. Electrode having high standard reduction potential. SRP means standard reduction potential is right hand electrode. So you can apply this for other numerical problems which has been solved also. So where you find the higher value of reduction potential, that means that is taken as RHE. Therefore E naught of cell, we are asked to calculate EMF of the cell. It's nothing but E naught of cell, which is equal to E naught of RHE minus E naught of LHE. What is E naught of RHE now? Here a clue has been given or a hint has been given that higher the value of standard reduction potential, it will be the right hand electrode. This is minus 0.76 for zinc, but for copper it is plus 0.34, which is highest for copper. Therefore that is taken as RHE. So substitute 0.34 minus, here left hand electrode is that of zinc. Zinc is minus of 0.76. So you get the value as 1.10 volt. 1.10 volt, which is the EMF of the given cell. Hope it is clear. that whenever you're asked to calculate EMF of the cell, just you'll have to take the difference between right hand electrode and the left hand electrode. How you will be deciding that which is the oxidation half cell and which is the reduction half cell is by looking at its reduction potential. If the value is greater, then that is taken as right hand electrode. Even in the previous one you had 0.8 and the other one more value, isn't it? We took 0.8 as the right hand electrode potential value or EMF. That's because higher the value, that will be considered as right hand electrode. So do calculate this, solve the numerical problem, and we will solve even more problems in this unit, because in this unit you can expect a numerical problem also. So you'll have to give importance for the numerical problems here. Then we will discuss the further concepts of electrochemistry. Please do practice writing the equations. A Nernst equation is very important. The solution and Gibbs free energy or equilibrium constant expressions, all those are important along with the terms.